Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the world of Kubernetes controllers, specifically the common pitfalls developers encounter when building them. It's a topic near and dear to my heart, and I'm excited to share some insights.
Absolutely. I've always found Kubernetes controllers fascinating but also intimidating. What are some of the biggest hurdles new developers face?
The biggest issue is the deceptively low barrier to entry. KubeBuilder makes it incredibly easy to get started, but that ease can mask the complexities of designing robust, production-ready controllers. Many developers fall into the trap of a working implementation that quickly becomes unmanageable.
I see. So it's like building a house with a great foundation but then using cheap materials and shortcuts for the rest?
Exactly. The article highlights several key areas where developers often stumble. First, designing custom resource definitions, CRDs. You need to understand Kubernetes API conventions deeply. It's not just about creating a Go struct. It's about understanding the semantics of fields, the distinction between spec and status, and how to effectively embed child objects.
Right, the spec defines the desired state, and status reflects the actual state. I've seen that overlooked often. What about controller design itself?
The article strongly advocates for single responsibility controllers. Each controller should have a clearly defined job, just like the core Kubernetes controllers. Trying to cram too much functionality into one controller leads to complexity and makes it harder to maintain and debug. Think Unix philosophy: small, well-defined components working together.
Makes perfect sense. And the reconcile method? That seems like a critical area.
Absolutely. The reconcile method is where the magic happens, but beginners often end up with spaghetti code there. The article suggests establishing a common controller shape, a consistent structure for the reconciliation flow. This creates guardrails and prevents inconsistencies.
Interesting. So a kind of best practice template for the reconcile method? What about handling status and conditions?
Crucial. Properly reporting status and conditions is essential for monitoring and troubleshooting. The article emphasizes using conditions similar to Knative's approach, providing a high-level way to report the state of the resource. And using observed generation is key to understanding whether the reported status reflects the current configuration.
Observed generation. That's something I've often missed. It helps avoid acting on stale data.
Precisely. Another critical aspect is understanding the cached clients used by controller runtime. They offer performance benefits but can lead to issues if you're not aware of their limitations, especially regarding read-your-writes consistency. The expectations pattern is crucial here to handle potential inconsistencies between the cache and the actual API server state.
So essentially, you need to account for the fact that the data your controller sees might not be completely up to date? That's a really important point.
Absolutely. And fast, offline reconciliation is key for scalability. Avoid making unnecessary API calls when the resource is already up to date. Efficiently managing the work queue and understanding its resync mechanics is also vital for performance and responsiveness.
This is all incredibly valuable information. The article also mentions the importance of carefully considering the return values of the reconcile method. What are the key takeaways there?
Yes, understanding when to return errors, requeue, or requeue after a delay is crucial. It directly impacts the controller's behavior and its ability to handle various situations effectively. The article concludes by recommending studying existing controller implementations like Cluster API and leveraging resources like the Operator SDK's Best Practices Guide. It also suggests a practical exercise to solidify understanding.
This has been a fantastic overview. Thanks for breaking down these complex concepts so clearly.
My pleasure. Remember, building robust Kubernetes controllers requires a deep understanding of the underlying architecture and careful attention to detail. But with the right approach, you can create powerful and reliable tools. Thanks for listening to Tech Bytes and News. Have a great day.
Bye-bye.